Good morning, everyone. Morning. How do you feel on Friday morning? Tired. Awesome. Okay, good. So hopefully you've got a lot of energy today, because today is going to be the brain frying day, especially if you are sitting on this session and if you're going to join me on the last session that I got of the day. So today we are serving a small piece of knowledge. So hopefully you had your coffee in the morning and you got some carbos and you're full of energy, because this session and the other one is going to be pretty intense. So let's begin. Yeah, so first of all, of course, I have to introduce myself. My name is Paula J. And what I'm doing for a living is I'm driving a company that is called Secure, which I established 8 years ago. And the company has 3 locations, Dubai, New York, and Warsaw. As you probably recall by my Eastern European accent, I'm from somewhere over there, and I'm technically from Poland. And I'm a penetration tester, as simple as this. So some people call it hacking, what I'm doing. I call it researching. It's a little bit nicer way to describe it. And I do have access to the source code of Windows, and that is pretty much something that really helps me to understand what's going on in the operating system, with not only by myself, but also with the team. So what we're going to talk about today? Today we're going to talk about the memory analysis. So how do we approach that? How do we make memory dumps? What kind of information we can find in the memory dumps? And how you can take the memory analysis to your regular work so that you are able to make it useful for you. And that's my goal for today, to present you the memory analysis techniques, how to make the dumps and how to connect to the dumps and how to analyze, different kinds of situations. Okay, guys, so whenever we are thinking about the whole session and the inspiration of the session, there's actually one thing that made me motivated. Well, first of all, I got a friend. And this particular friend is a very nice guy, but he cannot find a girlfriend. And, what can we say? Yes, not everybody is, of course, in his situation. But the thing is that he signed up for this kind of dating portals, yes? Who of you is on a dating portal? Hands up. Okay. Some of you are shy, of course. But what my friend did, he signed up for a portal like that. And then he found a very nice girlfriend. And he liked the picture, he liked everything. So pretty much he set up a date with this girl. So they went together on a date, and later on he came back to me and said, hey, listen, I'm completely unhappy because the girl, obviously, that was on the picture that I thought that I'm talking to her, that was a completely different girl. She was like a couple of pounds more, she was like older than she said, and it wasn't the same interest really. So very sad story. I'm like, hey, listen, you know what? Well, there is a solution, obviously, for that. If you want to prevent that kind of situation to happen, what you need to do is to set up a Skype call with her and see how she looks like, if you like her, and if you like her, like all the way, all the things about her, and then you're going to go for a date, okay? He's like, yeah, that makes sense. So what he did, he set up the Skype call with another girl, and pretty much everything was as if it was planned. He was quite happy. So he went out for the date, and then he went back and he's like, you know what happened? I'm like, no, that wasn't her on a Skype call. I'm like, what do you mean? Like, that was her sister. Oh my God. And I'm like, I'm so sorry for you. So there's only one conclusion that comes out of this simple story, that deeper research never hurts. Whenever we are thinking about the whole memory analysis, that's the full beauty of it. So whenever we've got this memory dump, sincerely, you can spend minutes, days, hours, months on analyzing it, and it always can go deeper and deeper and deeper, and you can get more fascinated, find out more things, what is going on over there, because there is a big chunk of information to be analyzed. Of course, at the end, we ask ourselves about what's the sense, what's the goal of sitting for 1 month on one memory dump? Probably nothing, but you can spend that time on analyzing different kinds of situations. Another small motivation for this presentation was actually our developer, Michael, he's an amazing guy. I'm mentioning him in a different kinds of presentation as a very unsocializing guy. And I mean, you will not believe how unsocial he is. Completely unsocial. He is afraid to talk to the customer. I mean, we never send him because he doesn't want to, because he's scared. Like this. I'm like, Michael, just come to the customer. I mean, explain, you're so smart. I think personally he's a genius. But he's so smart. He's like, no, probably they know more than I do. Yes, probably I'm going to humiliate myself and so on. Like, just stay home and be whatever. Yeah? So he right now sits in front of the computer and he does different kinds of tools, for example, that I'm also presenting on a presentation. But I was going to say one thing. Michael is a very nice guy. He likes to help people. That's his hobby. Well, doesn't sound very vicious, right? What he does, he helps people to analyze malware. So whenever you've got these forums like Bleeping Computer and a couple of other things like this, Michael is pretty much one of the contributors. He's very active and very good over there. And what he asks people for is, hey, if you want me to help you, you need to provide me the memory dump. And it's unbelievable that people actually do. Because if we need help, and if we really drastically need help, and we are like, oh my God, I have to do something. Is there anyone that can help me? You're going to share whatever you've got so that someone's going to solve the problem for you. And people share dumps. Do you know what Michael also does? He collects people's passwords. Because that's exactly what we can find in a dump. And a couple of more things as well. One of the pretty interesting stories was that he was actually analyzing, not really long time ago, the computer of one of the guys at work that was too ashamed to admit that he had some malware infection. So he told us a story. We're like, seriously? So what this guy did, he sent him his memory dump. Do you know who this person was? It appeared that this person was the corporate accountant being working on the application that displays the salaries of pretty much everyone working in this company. If the local database was loaded to the memory, we were able to extract it so easily. And now you can list all the details. So sharing memory dump, just to say at the very beginning, is a very dangerous thing to do. You know, I'm also very not a romantic person and super 100% of pragmatism. And when I become familiar with computers and all these things, I had only one sentence, or a couple of more, but one very important sentence in my mind. And that sentence was, whatever works, it's in a memory. So every time we are analyzing something and we are like, oh, where can I find this information? If something is working, it's going to be in the memory. So memory analysis and this whole capability of doing this is very useful whenever you've got problems. For example, the software is crashing. You want to solve that. Yes, for example, on the web server, web app, it's taking 100% of the CPU. You want to solve that. What do we do in situations like that? Well, obviously, memory dump. And then we go politely to the knock developer's room, and then we handle the whole thing over there. Like, could you please do that? There's an apple pie. So what we are thinking about whenever we are obviously analyzing memory is that it contains a lot of different kinds of information. And whenever we are taking, of course, the memory analysis, then we need to prepare ourselves to spend a little bit more time on it because it's not the easiest subject ever. This is our agenda. Memory dump analysis and dumping techniques, and live memory analysis. So in the first two parts, I'm going to show you how to make memory dumps, how to be able to read information from memory dumps, what do we see over there. And in the second part, I would like to show you how we are able to do the live analysis of the situation within the memory dumps. We're going to steal a couple of things from the memory, not only passwords, but a couple of other things. And I would like to show you how we are able to do that. Whenever we are thinking about the tools, well, I'm going to use a couple of our tools during the presentation. You're going to find them in the tools area on the website. There is a tile, you go directly over there, and then you're going to find pretty much all of our tools loaded. And whenever it's about all the different tools that I'm going to use the Mimikatz that I'm always super proud to use because our team is engaged in the Mimikatz development. That's the first thing. Today, by the way, if you're going to come on a Friday, on today's last session, we are doing the World Mimikatz premiere it's the first launch of the certain functionality of Mimikatz. So after that, Mimikatz is going to be available. That's one of the things. Second tool that is really nice is the volatility. And volatility comes in two flavors. If you are interested in doing memory analysis, one flavor, it's an executable. Another flavor, it's Python. Executable, it's worse. Why am I saying this? As simple as this. Volatility is a community tool. That means that whenever we've got community working on a tool, well, usually it's like Linux, Python, ARIA, that kind of, yes? So whenever there's something new appearing, it's going to be obviously in the Python script first, and then it's going to be an executable when someone's going to find time to compile it. So Python, unfortunately, is the answer. Well, fortunately, unfortunately, you have to configure it, and if you configure it already, that's fantastic. Okay, guys, so before we move forward to the presentation, I got a small introduction regarding the demo. And that particular introduction I called Hidden Process Crunching Handle, and there is a reason for that. So let's have a look what we've got. Well, first of all, I got over here the virtual machine, this body over here, where there is a malware running. And I name it significantly enough, yes? So you have no doubts. There is a process. What is my thing? My thing is that in operating system, we've got a very interesting mechanism that is used to list processes. And I want to start from that because it's very important. So what you see over here, it's not or may not be what you get. And we are not talking about Task Manager. I got my personal very positive opinion about this tool, by the way. So I'm showing this because everybody knows it, yes? But if you're going to use Process Explorer, Process Hacker, whatever, the result's going to be the same. What mechanism we are talking about? We are talking about the mechanism that it's called active process links written together. That is the mechanism that is it's a part of the process in operating system. Technically, it's a part of the structure that is called e-process. And whenever we are thinking about process creation, process to be created needs to have a certain parameters, like, for example, process ID, process name, yes? Active process links entry, it's one of them. So what is this, and why we are so grateful that we have it? On the other hand, it can be pretty negative because it's quite not difficult to maintain it. So active process links allows us to list processes from the memory just like this. When we open Task Manager, we're never like, oh, thank you, Task Manager, we're so grateful that you are displaying processes so quickly. We never think this way, yes? We just display Task Manager, processes are there, perfect, knowledge, check, and then we are all set. So we don't really think that some memory had to be scanned. Some, whatever you've got, 32 gigs of memory, and they had to be scanned. So it takes time. So why it works so fast? Because this mechanism, it's a little bit like, I compare it a little bit like to the kindergarten, yes? So when you've got the kindergarten, and on this side you've got Anna, and on this side you've got John, and here is whatever, Paula. So when Anna comes in, yes, I'm here, there is John already, yes? So we are like shaking hands. When Anna comes in, she's like, oh, hi. So we shake hands with Anna. So I'm already with two kids over here. But if I would like to be a very vicious kid, what I'm going to do, I'm going to take the Anna's hand and take the John's hand, and I'm going to connect them together, and I'm going to hide myself. But if someone asks me, hey, are you in the building? Of course I am. But I'm not the crew of this party. Yeah, they have fun separately. I'm just like there. But I'm still a legit process. So it's very much what we are describing right now. So what I'm going to do, this is, by the way, the technique that I'm using right now. It's called DKOM, Direct Kernel Object Modification. And if you want to know the details how to set it up, but because I'm going to hide this process from the list, then you go to the tools and there is a txt file. It's called labs.txt, and there is an instruction of all of the commands that I have executed to set it up. Yeah? So next stage, it's pretty much go to the debugger. So I got a debugging tools for Windows set up. And what I'm seeing over here, that in this particular case, I got two processes. This is the John, this is Anna. It's a list. It's just like literally hand-by-hand list. So whenever I change it, and that's what I'm going to do, I'm going to pretty much impact, so let me move on, how this process is going to exchange hands. So have a look. I'm going to modify, so this particular one is John's hand, and I'm going to modify the Anna's hand, and then I'm going to click go. So if I click go, so make sure that you're going to pay attention, there is a process that is selected in blue. So when I click go, it should disappear, okay? So 3, 2, 1, disappeared. But you know, this malware was running, and it's still running over here. That is the same icon. It's still there. So why it's not on the process list? Why should it be? Who says so? It's just like when you go to the kindergarten, you sign up for the registration list. But if you're going to be like, I'm going to sneak out a little bit, yes, it's fine. It's just very helpful for someone that is controlling that to say, we've got 13 today, yes? So that is pretty much the mechanism. Okay, guys, so now we could be like, okay, so how we are able to find the approach, find all of the stuff, so that we are able to, let me run this as administrator, should be fine, how we are able to find this hidden process, yes? So Process Explorer is starting. Very simple thing. There is one guy in the building that knows. One guy that controls them all, and kid will never be signed up for this kindergarten if this not this guy. And this particular guy, I have it, let me sort it by the name. So we got it. This particular guy, it's called Client-Server Runtime Subsystem. And Client-Server Runtime Subsystem, if we go to the view, lower pane view, and we display ourselves its handles, we will be able, sorry for the view, I'm going to enlarge it in a moment, we'll be able to find out a certain process that apparently is hiding. Not in this one, we've got two, but one local security authority subsystem. We can have two, in this particular case, we've got two client-server runtime systems. Okay, so I found something interesting right now. And that interesting thing says non-existent process. Okay, well, it doesn't look like something is hiding. You know, I'm all the time laughing, and maybe it's a little bit of Polish approach. My grandfather is very special. In Poland, we've got this kind of something that we call a Russian market. I mean, it's a community thing, yes? And in the Russian market, you could buy the cheap stuff, and you can technically buy everything, yes? If you want to, like, buy the nuclear weapon, probably that will be also possible, yes? For, like, $2. So, basically, whenever you get there, what my grandfather did, he bought himself a clock, like the regular tiny table clock. And he brought it. And he did the same, by the way, with the radio, so it doesn't really matter. He brought that, and he took this like daily newspaper, he put it on a table, and then he took this device, and he like put it into all of the pieces, yes? And he's like, that's how it works, yes? It was working before, but okay. So he took this all together, yes? Then he checked it out, worked back again. And he's like, but it's not the same device anymore, because he already knows how it's working. It's pretty much the same story with the operating system, by the way. It's kind of like you paid for it, right? You paid for it, which means it's completely yours, which means you have to, and you're responsible for knowing everything that is running inside. So can things hide in your own house? You're going to be like, no way, it's my house. Exactly, that's what we are talking about. Can things hide in our operating system? Not really. This is my operating system, and we should be able to find all the things like this. So there is this non-existent process. How do we know, by the way, this is the, as you remember, 3568. How do we know what kind of process is this? Well, there is a way, of course, of finding out. There are a couple of ways. One of the ways is go through the debugger, and I'm going to break into the debugger, and I'm going to type !process, 0n, and then 35, and then we've got 68 as the ID. And the command stands like this. As simple as this, at the end, I'm going to add 0 to display the basic information about the process. And obviously, whenever, of course, it finds it under the process ID in the memory, I'm going to have all the details about the process running. It's just not on the list. So my point of this demonstration was to show you that nothing can be hidden because it's always in the memory. It's working, it's in the memory. As simple as this. Okay, guys, so the whole situation, I'm not sure if you've got some animals at home, but the whole situation reminds me something like this. Yes? Like nobody can see me, right? Everybody can see you, I mean, but it's a hiding process, non-existent process. Oh, thank you so much. I mean, you were there, but you cannot see everyone. So that's pretty much the whole scenario. Okay, guys, whenever we are thinking about the whole approach, is there any other way to be able to analyze memory and discover the processes like this? Is there any other way? Of course there is. What we can do, we can also make the memory dump of the certain machine. And of course, I'm going to explain how to do that. But what I want to show you is one more thing. Whenever we've got the memory dump already made, just a small introduction. I'm going to take this machine because we don't need it anymore. This thing that we see over here, it's the result of volatility. Volatility, as we already mentioned, is the tool to be able to analyze memory. So in this particular case, let's just focus on the result. I'm going to explain how it works in a moment. But what I'm doing, I'm analyzing the dump using the certain profile. In this particular case, and again, when you're going to be playing with volatility, you're going to be like, oh, seriously? So many things are not working. Be patient. Grab yourself, nice cup of coffee, a couple of spare hours, yes? Like, have this positive approach, because it's going to be, at the end, a little bit negative. Well, I'm warning you, because a lot of things that are with volatility, they're written, everybody says they're working, but they're not, yes? It's lovely. Everybody says, oh, I did this, I did that, and then you run it on your computer, and then it doesn't. And then you talk to people, and they're like, did you manage to start it? And they're like, no, I didn't, yes? So there is this thing, magical thing, that you will need to handle with that, obviously, because it's a community written tool, and we can expect a lot, though sometimes the quality it's not the first priority. So whenever we are thinking about the profile itself, right now we've got a beta on Windows 8. You need to pretty much test it out. It's coming, yes, it's coming. People are working on the new modules. It's becoming more useful and useful. Windows 7 is great. Windows 8 is still crawling, yes. So this profile, why do we need it? Because every operating system has its own memory patterns, and these memory patterns are, of course, defined in a profile. What does it mean, this PS scan? It means process scanning, but process scanning based on the handles of the client-server runtime subsystem. So this is actually pretty great, because when we are analyzing, and that's what we did, the handles of the client-server runtime subsystem, it shows us the process that was not existing. Because if there is someone that knows in the building what's going on, it's definitely client-server runtime subsystem. Very knowledgeable guy. So what do we see over here? If we have a look at the processes list, yes? So as you see, there is this malware.exe. It has obviously the different process ID because I made a dump first. And that was the process that's hiding. How do we know what's the difference that it's hiding? Well, I will show you one more thing, okay? So this is the PS scan. It takes a while, by the way, to run it. So if you got, like, as I said, 32 gigs, then it's going to run for like half an hour, yes? To be able to analyze, are you the process, excuse me? Are you the process? Or you are the process? You are the process. Okay, so all of the handles that client-server runtime system has to the processes, they're going to be questioned. Right now, I'm going to do one more thing, PS list. So the module is like this. This part of the volatility we call a module. So we've got different kinds of modules. There is a very nice documentation on the volatility website, very nice. It's about 30 pages about different kinds of modules. Recommended. If you like the subject, that is a mandatory thing to start from. PS list, though, it's just a regular question about active process links. And that takes a small moment, yes? So as you see, we have launched the scan, blink, and then we got it, yes? So where is, in this particular list, it was somewhere here, where is in this particular list malware.exe? We don't see that. Why? Because we did the query that is not detailed enough. So making the memory dump can reveal plenty, of course, of information. Okay, guys, let me take the console out. Let me take this debugger out. Okay, and let's move forward. So whenever we are thinking about the purpose of the memory dumps, there are plenty. As I've mentioned already, application is crashing, yes? You've got a situation, for example, that you've got a connection that is established somewhere by the application to the database. You try to sniff the network, password is encrypted, you are not able to get it, probably you're going to find it in the memory. Yes? You do the memory dump of the process, you get your password. There are very popular, if I mention the name 100%, you will know different kinds of products that are using the connectivity to the database business-wise, and then the password is actually in the memory. Yes? So memory reveals you a lot of details. But whenever we are thinking, of course, about this interesting part, where we can use those dumps for, are they dangerous? Which processes we should not share the memory dumps of, and so on. Let me, of course, show you one thing. One, it's going to be the practical usage. Another one, it's going to be also practical, but if you want to be vicious in your infrastructure. So, what do I have over here? It's the application, and that particular application, it's called Leaky App. Probably, I mean, if you are a developer, you're going to laugh already, because my Leaky application, it looks very simple, very, very simple, and it looks like this. Ta-da! So this particular application, what it does, I mean, if there is someone in the world that you really don't like, you can give this person this application and advise this person to click on the memory leak button. This application was written to do one nasty thing, a memory leak. It's a by-purpose written application. It's for the education purpose. We did that so that we can learn how to handle memory leak. Of course, this memory leak is extremely fast because it goes like, yes? If you run it in an uncontrolled way, it's going to kill your system for sure. Yes, that's why I say if you don't like someone, it's perfect gift. You know, not everybody will like the world, right? Okay. So what I'm going to do, I'm going to actually run this application in a controlled environment because I'm going to use, for that, the proc dump, and I'm going to do the counter here and monitor the virtual bytes because this is where this application leaks. So I have defined Leaky App with the process ID, and then this application, the dump is going to be made when the application reaches 500 megabytes of the virtual bytes used on the memory. So whenever you've got applications that are growing on the memory, that is one of the techniques how you can start the whole analysis. So let me do that. So I'm going to start, of course, the counter right now. Oh, let's see what happened. Process, Leaky App, virtual bytes. Oh, it's actually, should be fine. That is pretty interesting. We've got the Leaky App. Yes. Yes. Sorry, my fault. Of course, we have to define which process we would like to monitor against what kind of counters, yes? So as simple as this, leaky app.exe. Perfect. So now we are all set. Now we are waiting, perfect, to make the goal. And the application, when it's just running just like that, it doesn't do anything. But I would like to show you how does it work against the counters. So we will need to make some space over here so that it looks pretty for everyone. So what we're going to look for is one thing. This virtual size needs to grow to 500 megabytes. When it does, the memory dump will happen. And if you got a counter like this within the crashing application, when the application reaches some kind of counter, you can specify whatever that is. 100 CPU, whatever, 80% of CPU, make the memory dump, yes? Whatever you're going to figure out that is available in the performance monitor, then the dump obviously is going to happen. Okay, so as simple as this, memory leak. And what is happening, as you see, the virtual size, it's growing. I'm going to enlarge it a couple of times, you see. So it's actually growing pretty fast. So right now it's pretty much 300. And whenever, of course, it reaches 500, the memory dump is going to happen. And that is something that you can take for the further analysis and specify why your application was actually leaking memory. So this is one of the approaches. So we are very close for the dump to be made. So 400 and pretty much over there, 74, and then you see 10 seconds, dump is made. So this is the automation whenever you've got your, for example, especially worker processes crashing on a web server. Perfect. Make this kind of trap, because you never know. You will not be sitting in front of the worker process, W3, W2P, and you're like, okay, right now, yes? That would be kind of weird. So in this particular case, we can, of course, let me kill that, work on the application like this. So this particular, and that is actually a pretty cool number, yes? How do you, it's like I always call it a raccoon million, yes? Whatever. Okay, so let's take it out. So this is one of the approaches. Okay, guys, so the next approach is actually pretty interesting. So if you would like to make the memory dumps, how do we make those? Well, there are different kinds of techniques for doing them. One of the things is pretty much do the dump of the process, and another type of that memory dump is the memory dump of the system. Obviously, the system one gives you so much more information because it gives you the whole context, yes, what kind of libraries were not loaded so that your application was crashing and so on. And in this particular case, what we see is pretty much, in the case of process, it's pretty much whatever was happening in the process. Also very useful. So how do we make the process dump? When someone's going to ask you, hey, could you please make me the dump? What are we going to do? Well, there are plenty of things, plenty of tools, yes? Starting from our favorite, Task Manager, as simple as this, we are able to make the dump as simple as this. So right-click, and then you pretty much create the dump file. And this option is over here, yes? So very simple. There is actually a pretty interesting process. Oh, there we go. Pretty interesting process in Task Manager, well, in operating system in general, that is called Local Security Authority Subsystem. And Local Security Authority Subsystem is the one that we are completely interested in, here we go, because this guy is containing all of your so-called secrets. And it's really called like this, with a capital S, LSA secrets. I mean, if it's called a secret, there must be something interesting, right? So whenever we are thinking about making a dump of that, definitely we can do this. So create a dump file. The dump file is created. I will not analyze my personal dump in front of your eyes. If you don't mind, you're going to know a little bit too much about me, I believe. But I'm going to analyze the test dump that I have prepared. And that particular dump, it's the dump that is called demo lsas.dmp. One more thing to mention. If I right-click on it, there is this thing in the shell. And why does it work like this? Well, due to the contribution of an amazing guy, Andrew Richards, he is working at Microsoft, and he is responsible for recording over 100 really amazing, I love them, videos that are called defrag tools. And if you go to the defrag tools website, you can very easily find it. Defrag tools has pretty much nothing to do with the whole content. But what the movies are about, they're pretty geeky. I mean, if you will have nothing to do in the afternoon or when you are in the holidays, lying on a beach or something like this, take the tablet and then watch them, because it's perfect, yes? It's a perfect, I find it as a perfect entertainment. Very educational. Okay, so what's my point? My point is that you can add, you can add the extension to the shell like this to be able to open any kind of DMP in a debugger. Extremely useful, actually mandatory. Where do you find this kind of shortcut? Where can I find it? You can find it if you go to the defrag tools website, to the main page. There is a link to OneDrive of Andrew. And you go over there, and there is a registry key that will tell you exactly what to do. It's just an entry in the registry, obviously. Defrag tools, main web page, there is a link. You're going to find it without any problem. If you will not, just let me know. Okay, so what I'm going to do, I'm going to open the dump. And then dump, of course, opened in the debugger. Lovely. And what I'm supposed to do right now is to pretty much analyze it. Question is how I'm going to analyze it. Well, you need to know what you are searching for. Yes, it always requires some entry knowledge. But in this particular case, I'm going to use the tool that I was mentioning before, so Mimikatz, but I'm going to use it as a DLL. So quite unusual. So I'm going to do dot load mimilib, so like this, dot load mimilib, and I'm going to load pretty much the Mimikatz library. I mean, if it's about the usefulness of the tool, it's so difficult. Just kidding. I mean, the thing that we have to run, it's the exclamation mark Mimikatz. Yes, like, ooh, are there many other options? No, you just need to read this. I mean, thank you, Benjamin, for the help like this. This is perfect. So, Mimikatz. Think. Great. Then it analyzes all the stuff that we have in this tiny process, including, obviously, all the different kinds of usernames and passwords. Yes, local ones. Yes, the domain ones. Yes, everybody else's that is logging on. Yes, also everybody else's that logged off. But the LSASS was kind of busy. And I'm sorry, we didn't manage to take it out from their memory. Yes? Kind of not nice. So whenever we are thinking about those, this is just a piece of cake. We can find a little bit more information, and that's what our session is about. So this is the small analysis, yes? And try to do this in your computer, see what is coming out. Try to do this on one of your servers. This is pretty much pain in the back. During all of the penetration tests, I mean, it's so boring. I'm like, my job is so boring. I'm like, not again. Administrator didn't log off. I got all the passwords, obviously, yes? So that is the case. And I don't have to run any kind of tools on the server, right? You just go to the task manager. I mean, all legal. Click memory dump. You take this LSASS to your computer. You analyze it over there. Easy. Easy peasy. So let's take it out. Okay, good. So this is how we make the memory dumps. Okay, here comes the next question. How to make the memory dump of the system? Because that's kind of more challenging. Well, you can use the debugger for that, but let's skip this debugger already. Let's use something cool. So something cool that I'm going to use, it's going to be the tool. And let me have a look. Perfect. I'm going to start the console on my side as an administrator, because you need to be an administrator to be able to make the memory dump. And I'm going to go to my D drive, to tools, and to the memory tools. So what kind of tools we've got over here? Well, first of all, I need to mention the tool that it's called Dumpit. And Dumpit is, in not only mine, but in many people's, one of the best, if not the #1 tool to be able to do the memory dump. It's written by Matthew Seuss. You can download it for free from his website. You will find it very easily, but I need to mention one thing. Don't get me wrong, I'm not doing any kind of marketing. I'm actually not very good at advertising, things like this, but one thing is interesting. If you would like to analyze the 64-bit operating system, it requires the driver that is digitally signed. That means Matthew had to spend some dollars to be able to have the certificate. That's why if you want to analyze the 64-bit operating system, the tool costs $199, something like this, yes? Seriously, I think it's completely worth it, and everybody is using it. It's just doing the dump. I mean, could it be really simpler? So let's have a look. How does it work? So if I run Dumpit, if I do have obviously enough space on the disk, it tells me in this particular case that I don't have enough space, but it doesn't really matter. What I want to show you is that what it does, it gives you the information, how much memory, I got 16 gigs, is going to be saved on the disk, and the next thing that you need to click is literally yes. Yes? Do you want to make the memory dump? Yes. Yes? And then the memory dump is made. That's the whole philosophy. And then we are ready to have party and analyze, of course, all the things that are in this dump. Dump it, have a look, very nice tool. Okay, guys, so whenever we are thinking about these dumps, there is one thing, obviously, that we should remember. That whenever, of course, you are playing with the memory and you make the memory dump of the whole operating system, just to sum up, whole operating system, you're going to find all of the hidden mechanisms, if you do have anything hiding, that was obviously in the operating system. But as well, you're going to find your personal information, if it's your personal computer, to be able, of course, to extract passwords like I did, and a couple of other things. Okay, so whenever we've got the dump made, Question is, and it's a very basic question, what do we search for? What kind of information do we search for? So whenever you are analyzing malware, we're going to search for the processes, handles. We're going to search for different kinds of hooks. We're going to search for eventually some history that was made in this operating system. Question is, how do we do that? Well, you know, to make it super simple, Volatility actually provides different kinds of modules that are allowing you to, for example, list all of the things that I've mentioned over here, just like this out of box. That's very cool. Have a look at Volatility. I mean, I would say that if you want to start analyzing memory, if this subject is new for you and you want to jump in, what should be the first step to take? Well, 1, read the manual for the Volatility. 30 pages doesn't hurt. Second thing, download Volatility, of course, in Python, please. Download Python, small suggestion, guys, 32-bit, okay? You can analyze 64-bit operating system images with the 32-bit Python. It's fine. Yes? You don't need a 64-bit. Why not? Because most of the modules in Volatility, they are not written, as I said, community tool, to be able to handle the 64-bit Python. 32-bit. Yes? And then you are ready to go. Eventually, if you want to feel a little bit more comfortable, you download yourself something that is called ActivePython, so that you don't have to type Python, py, yes? But you just fire up the Python scripts from whatever you want. And that is very comfortable. So 3 things, ActivePython, Volatility, and Python. This is what we need to start the whole adventure. Okay, guys. So of course, the question is, what kind of information, what's more that we can find in the memory? How to search for the different kinds of specific things? And one of the interesting things to search for is handles. The reason why we're going to search for this is because if one process is, let me say, talking to another one, then obviously it's going to have a handle to that. Handle, as we described previously, is like a handshake. Yes? So, for example, very good example of the handle is that whenever you've got a USB stick and you are trying to safely remove it, and it says impossible, yes? It means that probably there is a handle to it that you, simply speaking, need to close. Why that happened? Well, bad things also happen in operating system. This handle wasn't properly closed. That's why it's still holding your USB stick. Can you just take it out? Obviously, yes, we are doing this all the time. But if you ever wondered what is going on, it's just a handle. How do we cope with this? You go to the Process Explorer, search for the handle, then you kill it, and then you can safely remove your USB stick. Yeah? So one of the examples where the handles are used. Okay, guys, but handles are also used in the different kinds of memory analysis, and handles are very useful to find out what was happening whenever we've got, of course, certain situation. So what I would like to show you is the small demonstration how we are able to find out information in the memory whenever we've got a memory dump. We are about to analyze it. Okay, so here comes the small analysis. What I'm going to do, here we go. I'm going to use Volatility to be able, and I'm going to analyze this analyze dump. So this is -f and analyze dump. I'm specifying the profile, one of that, and I'm specifying one of the modules that is called DLL list. The reason why I would like to find the DLL list is because what I plan to do this time is to extract the event logs from the memory. And before I do this, let me tell you the story. Why I would like to show you this? Well, very useful. We were engaged in a very interesting project. There is this customer that came to us and they're like, oh, you have to help us because we got a problem. I'm like, okay, well, what kind of problem you got? And they, simply speaking, had a very serious problem. There was an administrator that was pretty much sabotaging a company. It was actually a factory. So this administrator puts down the whole infrastructure. For example, all of the domain controllers, yes, like this, a couple of times. And why all of the controllers are immediately down? What's happening? Like, this is not a normal situation. Can you imagine that they stopped the production for, in that particular time, 2.5 days? That was the loss about, they estimated it later, about, in conversion, that's going to be about $3 million. You can buy some nice car for that, yeah? Or couple. Couple of cars. Okay, So whenever that situation was happening, they said, okay, you have to analyze it. You know how we did that? What we did is that we were obviously doing and all the searching and finding out what kind of activities this administrator was doing on different kinds of servers and so on, and we really could not find a thing. This guy was very smart and he exactly knew what he was doing. But, of course, he made one mistake. And it's always this one beautiful mistake that helps us, the other guys, usually the good guys, to find their stuff. So what happened is that he was actually deleting the event log files. Everybody can do this whenever you're a local administrator, it's just a file. So he was deleting them. But you know what? He did not reboot his computer. So one beautiful day, what we did, we made the memory dumps of the computers that were alive, and all these event logs that were used before, they were still loaded in the memory. So we were able to extract them, and afterwards we were able to sneak and check out what was going on, obviously, before he deleted the log files. So how do we do that? And why am I doing this through the DLL list? Well, as simple as this. The reason why I'm doing this is because I will need to grab the list of the handles of, first of all, I need to search for all of the DLLs that are launched over here per different kinds of processes. DLL list gives you the processes and DLLs that are loaded by these processes. Why am I interested in this? Well, event log service is one of the mechanisms in operating system that is started by one of the creepiest guys ever in the operating system. I mean, sincerely, I would not like to have a job like this. This is pretty much svchost.exe, and svchost.exe is a very boring guy, and he does only this, hi, svchost, can you please run this DLL for me? It's like, sure. Can you please run this? Yeah. Yes, this is svchost. So things in the operating system, yes, like DLLs that are in the form of services, they are pretty much over there. That's why I want to know which svchost has this DLL that is the event log service running, so that I can export from the memory all the file handles that the service is having, and file handle, it's nothing but the event log, yes? So let's do that. And that, of course, takes a small moment. And I'm going to save all the information to dll-list1.txt. And next part we're going to do, it's simply speaking to find out in this text file that we're going to have. Now we got it. So dll-list1, let's open it. I have it. This is our notepad. I'm going to find over here the service name. And the service name is WEVT. So event, and then we've got obviously SVC. And when I'm going to find that, perfect, I did, yes. Here I can find a, of course, entry for the service itself, but I can see that this is launched by the SVC host with the process ID 848. Very good. So 848 has handles to files in the operating system that I can extract from the memory as well. Give me just everything what you've got from your handles. One of those, it's going to be files. So let's do that. So I'm going to take, of course, 848, and then let's do pretty much the same scenario. But this time, I will not use the DLL list, but I'm going to use a different module, and that particular module that I need is going to be the dump files. So let's do that. Dump, without a space, dump files. And then I need to specify that, obviously, I would like to do that to, in this particular case, process ID, and I'm specifying paste, and then I need to, of course, specify where in which kind of directory I would like to do that. And in this particular case, I got a directory that is called file handles, and then enter. So what's going to happen, the result's going to come very quickly. What it does, it dumps me all the handles that are attached, kind of, to this process ID. That's perfect. So as you see by the extension on the right side, it's EVTX coming out. Yes? What is so nasty about the EVTX is that if you watch my presentation, CSI Windows from the last year, I was explaining and showing how to edit EVTXs. It's very, very hard. This file is very sensitive to any kind of structure changes. But when it's fully loaded, we can just take it and it's going to be perfect, it's going to be working, it should be working, and it's going to be importable to the event log. When we double click on it, pretty much like this. So what we have over here is the list of the different kinds of DLLs as well. And this is something that, I mean, all of the handles, yes? So everything that is there, it's the whole beauty. So what I'm going to do right now, let me show you. I'm going to use, to be able to work on this EVTX, just to make sure that everything is okay, we have written our own tool for that, to check the structure. Because as I said, it's sensitive, so it may appear that all the files are just crashed. Yeah, we don't want that. The tool is available on the tools, in the tools on the web page, yeah? So we can work on this with me. So what we're going to do, as simple as this, let me go to the tools, and then the logic is going to be actually pretty easy. So I got a tool, it's called EVTX Recovery. And EVTX Recovery has two folders that it's working on, in and out. I kind of call it blunt logic. You will see in a moment why. Because of the parameters that we've got in the tool is in, out, out. Oh, wow. But, you know, our developer not always has the social imagination. Okay. He's not offended, by the way. He knows that I love him and so on. So I can say all the nasty things about him, and he's still going to be fine. Good guy. No, he's just fantastic. Okay. So let's move on. So what we're going to do, we're going to, of course, get the whole result that we managed to export. Very good. And how does this result look like? Well, these are all the files, as you see over here. We cannot pretty much change the extension. As you see, by the way, we've got here EVTX VACB. This is one of the formats, yes? I mean, it's completely useless. You can try to rename one of those. Maybe you're going to be lucky, but probably not. So to be able, in order to check for the integrity, I'm going to copy all those things, and I'm going to paste them in. So that the result's going to come in out. So we got that. Very good. And now let's, of course, go to the tool, and let's use it. So the whole path of the tool, let me copy that pretty much, because we will need to move there using our pretty much console. So let's get there. And what I'm going to do, let me move it a little bit so that everybody can see that. Very good. CD, and then I'm going to paste, and I'm going to go to this folder. And EVTX Recovery takes, obviously, two parameters. One is the in, another one is out. Yes? Sorry about that. But it works. That's the positive thing, yes? So what I'm doing right now, I'm extracting, perfect, all the different kinds of event logs from the memory. And now we can go to the folder that is out to see the output. And this is great, because here we can see the legal EVTXs, yes, different kinds of. I'm going to take one of those, yes? And I'm going to open it right now by double-clicking in the event log. Let's see if everything is going to be okay. Where is the event log? Okay, it's importing. Very good. So what we can see pretty much, let me take this out and minimize it so that we can see clearly what happened, is that I got, of course, different kinds of logs here imported. And this is one of these logs. All of them that I have, well, this one actually failed, but because I don't have the file, yes? But this particular one is the one that we are talking about, because the rest, it's the cache. So here we are able to find out, of course, the whole scenario, yes? And what is really nice, as you see, the name is fine, network profile is exactly the file. So we are able to read right now what is happening in the memory, yes? All this stuff that happened, that someone apparently deleted, you are still able to grab that. Of course, there's one inconvenience, until the reboot, yes? If someone reboots the computer, all the stuff is gone. And the next thing you have to do is to trace whatever happened on the disk. And that's a completely different layer that we're going to cover later on within the day. Yes? Okay, so this is the whole setup. Okay, guys, one more thing. Whenever we are thinking, of course, about analyzing memory, there is also a couple of useful commands that we can use. And I would like to talk about that. What kind of commands we are talking about? Well, first of all, I would like to analyze then another dump. It's going to be a small introduction to volatility. So whenever we've got one dump of the memory, what other modules we can use? Because we have just learned about the dump files. We have learned about exporting the DLL, so DLL lists. What are the other ones that are interesting ones? Because obviously PSScan, PSList, this is easy. I want to show you something interesting. So one of the formats, I need to, of course, specify the profile. And in this particular case, profile is going to be Win7SP1x64. And then after that, I need to specify the module. There is a very interesting module. It's called consoles, or consoles in Spanish, I think. Okay, so let's move on, yes? What was the consoles, of course, yeah, not console. Okay, so what does it give us? It gives us one thing. We can see over here, it's pretty fast, though it gives a lot of results, yes? It gives us the output of what people saw as a result of the commands that they executed in the console. So if your server gets hacked, immediately make a memory dump, because you're going to see the whole history of the things that were happening over there. Lovely. You're going to say, like, oh, hacker learned this tool and that tool. Oh, and he saw that. Oh my God, he saw my password. Yes? Let's do something about this. This is the only way how we are able to see that. What happened? Very useful. And as I said, it takes a small time, but the result's going to be like in a moment. And then, of course, all of the history, here we go, that were of the commands that were executed is here. So as you see, someone ran Mimikatz, one of the ideas. Someone actually, here we go, privilege debug, log on passwords. Someone actually made a typo. Yes? Privileg. And we've got also dir. This is the result, this is the output of what people saw. Someone elevated to the local system, psexec. Yes? Someone moved around, fire up Mimikatz, went to tools. Yes? So you see pretty much all of the things that this person saw. Yes? Very, very nice. Of course, you can review all the results. It's plenty of information, yes? Plenty different kinds of information. And at the end, what I did, and that was for the demonstration purpose, I did the dump. What was the tool that I used? Dump it, yes? You see completely everything, of course, what was the output. Another one that is also used, let me do the Control-C, it's the, in this particular case, the CMD scan. CMD scan is another one, and again, pretty much similar, but instead of the result, it shows you all of the commands that were executed. So here you've got the results, here you've got the commands. Yes, it gives us a complete picture of what kind of tools were obviously launched over there. And of course, it takes, and again, small while. It's still pretty fast as for what we've got in the memory. Because normally you're like waiting for 20 minutes for the result, yes? This one is actually bang, and then we got it. So as you see, there is a whole summary of what happened, yes? And even more, it's going to give us the more result later on as well. Good. So what else we can find in the memory? What are the other things that are interesting? I will not be myself if I will not mention one tool. And that particular tool, it's called Yara. And let me launch it. What's that?
Type it, please.
Yara, by the way, it has the it's a Polish word, yes? It's to smoke a cigarette, by the way. So it's kind of funny for me when I look at it. Yara, she's smoking, that's what it means. Doesn't matter, yes? It's just language things that we see all the time. So, smoking 64. Smoking 64, what it does? Well, as simple as this, Yara, it's the community tool that is helping out you to analyze the memory versus patterns. So, what does it mean? It means that if you do have a malware that is defined, let's say Zeus. There was a malware that was called Zeus. Zeus, when it's in the memory, it does this, this, and that. There is a mutex like this, there is something like this, there is a DLL loaded like that. Patterns, yes? So when they're found in a memory, there is a result, yes, you've got Zeus. Who creates those patterns, though? People. Yes, so malware analysts. So when there is a very famous malware and you are like, oh, do we have it or not? I kind of don't know, antivirus doesn't say a thing. yes, then you can use Yara to analyze the memory dump and search for those patterns. Okay, guys, let's have a look. So what I'm going to do, I'm going to start it versus zeus.yar, which is the definition file. I will show you how it looks like in a moment. And I'm going to, of course, scan that versus zeus vmem, which is the memory dump. So as simple as this, Yara, of course, scans for the whole memory. And then when it lists me those things, it means that I got a Zeus. Yes? Not very breathtaking, I know. But very useful if there is something known in the market and you're like, oh, do we have this malware? How can we tell? Run it on a memory dump. Because as we remember from my previous sessions, I mean, antivirus, it's not really the case. Yes? We can have the tools and different kinds of solutions that are completely not recognized by antivirus. And then what? How do we know that we've got this? Yes? We have to analyze the memory dump. Whatever works is in the memory. So this particular malware is going to be there. Notepad, Yara, not the .exe. Sorry, Zeus, of course, not the Yara, but Zeus, Yara. Okay. So what do we have over here? Well, the whole patterns, they're extremely simple. As you see, we've got, for example, mutex that is defined like this. And that is what is characteristic for Zeus. What's wrong about that? Nothing. It's just a name. When it's there, it means you've got this. As simple as that. So very useful whenever you are afraid that you've got something that is known. Okay, guys. So one last thing to show you. Regarding the memory analysis, that is a pretty long demonstration. There is a very nice tool. And again, apologies, it's not a free tool, but it's very good. It's called Password Recovery Kit Forensic. What it does, it allows us to analyze different kinds of memory dumps, not only this, but what I'm going to use here is the analyze memory and decrypt the hard disk. So let me do that. And I'm going to do that versus BitLocker. So one thing about BitLocker, it's very nice. So first of all, let me mention what I'm doing here. I've got the memory dump over here made, and I got the encrypted VHD. As simple as this. I made the memory dump, and I did the disk do VHD. We got that. These two things. So next, it will show me something that I always call Microsoft Minutes. It's left 1 minute, 22 seconds. Yeah, just do your job, maybe, yeah? Okay, that's speed up. Don't believe that. It's more or less this, yes? So whenever we are thinking about the whole analysis, how the memory dump happened. Well, in BitLocker, there is one thing, and also in many other solutions like this, the key that is used, it's in the memory. Not a surprise. And it's not the vulnerability. It's the nature of the solution, yes? So whenever, of course, we've got something that is encrypted, we need to have something that is not encrypted so that we are able to access to this encrypted part. So in case of BitLocker, yes, then there is a driver, fvevol.sys, that's its name, that is managing the 48-digit password that is used to be able to access the encrypted data on the fly. That means that if it's in a memory, we'll be able pretty much to grab that. And what is this tool doing? It's matching whatever was in the memory dump with the disk image. And when it finds it, it's going to give me the result that, yes, we have found it, and then this is pretty much your password. It's going to be quite funny because now it's increasing, you see? Estimation 4 seconds, 5, 6. It's going to be over in a moment. But that is what it's going to give us. Be careful with one very important thing here, direct memory access. If you do have laptops in a company that have FireWire, FireWire has the DMA, direct memory access. That means that if someone comes with the FireWire cable, connects to your laptop, this person has the direct access, one-to-one, to the memory of your computer. Yes, including your passwords. So in the corporate policy, it should be always in the list that every single time you implement different kinds of cryptographic solutions like this, FireWire should be disabled. And whenever it's about BitLocker itself, it also stores the password in a memory, as everything like this. And as you see, this is the 48-digit recovery password that we can use for the recovery. So if the laptop is a bit locked, but it has the FireWire port turned on, door is opened. Yes? It's literally like this. Okay, guys. So whenever we are thinking about different kinds of system-related issues, let's move on. By the way, is it interesting? Thanks, thanks. You're so silent, and people in the US are never silent like this. So I'm like, they're always like, eh. So I hope everything is okay. Okay, good. So whenever we are thinking about different kinds of system scenarios, what kind of course, options we've got whenever we will be leveraging the memory analysis within the enterprise. I would like to show you one thing. And it's also, by the way, very useful if you are struggling with the situation that you've got the certificate and it has not exportable private key, and you're like, what am I supposed to do with this? Like, I cannot export it. You know, maybe it's a Polish blood that I've got with me. Yes, like if someone says no, I'm like, why not? Always. This key, it's not exportable. Why not? It's impossible. Nope, it's gonna be possible. It's just a matter of time and being stubborn. Yes? So the same story comes here to certificates. Let me show you. So what we're gonna do, as simple as this, let me take all these things out and clean out the view so that everything is clear. What we're gonna be playing with right now is pretty much Mimikatz that is written in PowerShell that can execute on the remote server. All the space cleaned out, perfect. So how do we launch that? How do we deal with this? Well, first of all, let me show you the whole background. So here is the virtual machine where, of course, we've got some certificates imported, cert mgr.msc, very good. So as regular stuff, current user, that's fine, certificates, perfect. And we've got here two certificates. One is the administrator, another one is the contoso.com. If I have a look, then it gives me the information that yes, you've got a corresponding private key with this certificate. That's great. So what I'm going to do, I'm going to try to export this particular one. And then it says, no, do not export the private key. Excuse me, this is my certificate. So where the private key is going to stay? I want it with me. That's an option, yes? If you see things like this, this is a lie, because because whenever certificates are in an operating system and they're in a personal container, where can we find them all loaded? In the memory, yes? So we need to do the memory dump, or we need to do a small trick to be able to go directly to the memory, harvest them, and then bring them back to us. And that's what we're going to do. So let's play. And for that, I'm going to use the PowerShell version of the Mimikatz, as I already mentioned. And all these different kinds of certificates that we've got, here we go, they're going to be exported to this tools folder that you see over here, this tools folder. And I'm going to do pretty much that. So this particular version of Mimikatz, where can we download that? Well, that is, if you pretty much send me an email, I'm going to send you the one. The PowerShell edition is available in public. You can get it. But this particular edition,
You want us to take a PowerShell script from you after we...
Yeah, that's exactly what I want. That is exactly. Mm-hmm. Okay, let's continue. You're asking very not comfortable questions, you know. Okay, so let's have a look. Probably I'm blushing right now, but you don't see it, right? Okay. Yeah, let's invoke Mimikatz. So in order to have it comfortable, I'm just going to invoke Mimikatz. So I'm going to launch it, install the function, so that I'm able to do invoke Mimikatz invoke. Mimikatz, and I can pretty much tab it as a function, yes, as a CMD let. Very good. That particular version, what it does, because I didn't mention in this whole your questions, you know, it has one thing. It connects to the memory of through the WinRM, yes, and then it executes the Mimikatz in the memory, which means it's perfect because it's not discoverable by antivirus, because it's in the memory of the WinRM hoster, of the WinRM hosting process. So it's just going to execute. It will never be on the disk, does the bad stuff, and then it brings through WinRM all the certificates to me. Good. So what I'm going to do, computer name, as simple as this, and then I'm going to specify the computer name that I want to attack, which in our case is going to be this guy in the back. And this guy's name is WS12R2-DC. That's exactly the name. And then I'm going to use the dump search parameter. Let me launch that so that we are all set. The command line looks like this, as simple as this. And, well, what else we can do but just press enter, yes? So when we do that, it connects to WinRM, to this particular server, and then it exports all the certificates over here to the tools folder, yes? So these are the ones. As you see, I got also not only the just regular certificates, but I got a certificate from the current user, including the one with the not exportable private key. Yes? Oh, did I mention it wasn't exportable? We just have a PFX with the key. So it's kind of, you know, this not exportable always makes me feel like, seriously? Security by obscurity. Okay, so what we're going to do right now, we're going to analyze it. And I'm going to put it pretty much to my tools folder. And let me, of course, show you where I'm going to copy the whole stuff. So in this particular case, I got my tools folder, and I'm going to paste it over here. Yeah, so we got it in the tools folder. And I'm going to use the command line in order to be able to get access to the private key of that particular certificate. And how I'm going to do this? Well, as simple as this. I'm going to use the tool that you probably all know, and that particular tool's name is OpenSSL. Yes, to manage different kinds of certificates, keys, and so on. So let's do that. So tools, and then I'm going to use OpenSSL, not the config, but just an executable, on that particular certificate, and I'm going to specify, of course, the standard, so PKCS, and then we've got 12, and I'm going to specify the password, and Mimikatz, what it does, it sets the password to export a private key, or in this case, going to be to import because it's a PFX file, in the following way: pass Mimikatz, yeah, like this, as simple as this, and then we need to specify the in. And in our case, the name of the certificate was cert. Yeah, so this is this contoso.com certificate. Let me enlarge that. And then we need to, of course, specify what we're going to do so that we would like to get the whole information, of course, about the certificate. So I would like to export right now the private key. Of course, I can do this in GUI, but this is a little bit better. You're going to clearly see what's going on. CL cert, and then notes. Here we go, notes. Okay, in order to be able to get all the information from the key itself. And as you see, begin private key, not exportable, not anymore. Yes? Thank you. Thanks. So this is pretty much what we see within the whole area within the memory. Of course, all of the different types of attacks, like Kerberos related attacks, assigning to yourself the Kerberos tickets, yes? You can grab from the memory Kerberos ticket, assign it to your session, and then move around the domain with this ticket because you've stolen it from the memory, yes? Passwords are also within the memory, yes? All the history of everything is in memory. If you are running the PowerShell commands, you make the memory dump, all the history of that is also in the memory. So as we see, every single thing that is currently running within your laptop, we're going to pretty much find it over there. Okay, guys, so moving forward, what we did, we have played with the different kinds of techniques for the memory dumps. We have also differentiated in between the system dumps and process dumps. You know what kind of information we can find over there. You've got your toolkit, yes? You know what kind of tools and what kind of modules, with particularly volatility, we can use versus what. Have a look, because volatility, it's a never-ending story. People are working on it. This is people's passion. And you're going to see crazy lot of information. Just start from the package I mentioned. It's a very good start, and it will not discourage you from the quite annoying environment like memory analysis, because you need to be like zen all the time, yes? Volatility, memory dump, perfect match, is going to work out. You're going to be positive and eager to find out more information. Whenever, of course, we are thinking about the summary at the end, remember, of course, that whatever works is going to be always in the memory, as we were repeating for a whole session. Whenever we are thinking about analysis, seriously, what I like about analysis is that every single dump is different, because every memory of every operating system is different. So the more dumps you're going to analyze, as simple as this, the more experience you're going to have, the more patterns you're going to see. More and more and more and more. Never ending, yes? You've got to also crash dumps. That's another interesting idea. Mini dumps in the operating systems that are made whenever blue screen is happening. If you're like, I would like to use debugger, I would just wonder what should be the purpose. Take the crash dump in the mini dump folder, analyze it over there. It's also the memory dump, though it's a very small one. It will tell you exactly what kind of reason was that your blue screen happened. Another reason to play with the memory. Obviously, do not share the dump with the other people. Yes? I hope that I kind of motivated that. Yes? Definitely not, because there is a lot of different kinds of personal information that you're going to find over there. You can even get the print screens, literally the pictures from what was going on, like this. Volatility has a cool module for that. Have a look for that. You can see exactly what was going on. And at the end, taking and having a look from the practical perspective, it's very comfortable, very useful for the troubleshooting. If you're going to have a problem with your app, yes, then you can always make the memory dump and then analyze it by yourself, or do it together with the developers if, brackets, you're going to be friendly enough. Yes? Okay, guys. So that's pretty much it. So thank you so much for attending. Thank you. Please, of course, fill out the evaluations. If you've got some questions, definitely let me know. This is the link of the tools. I'm trying to run to another session that I have in 30 minutes, literally on the other side of the building, which is the repeat of the hidden talents about the users. Go ahead and enjoy me. And if you are willing to get the $300 coupon for our Secure Academy, there is this guy over there with the t-shirt, what the heck? And he's got the ones. Thank you so much.